FRQ 25, molecular structure, enthalpy, kinetics, and stoichiometry. So for this first problem, we're trying to figure out how these four molecules will react together and split apart into this equation right here. 2H2O2 to 2H2O plus O2. So looking at this, I see that we have to get 8 water molecules, or not 8 water molecules, 4 water molecules, because they'll use up all 8 of our hydrogens. So I started doing this down here. So we have our 4 water molecules, leaving us with 4 oxygens, and we can just put them together with the O2 to make 2 O2 molecules. So we end up with 4 H2O molecules and 2 O2 molecules. So for the second one, it's asking us if the energy profile above is endo or exothermic. It is exothermic because it starts off at a higher energy than it ends with, meaning it releases energy into the environment, which is the definition for exothermic, and makes its enthalpy negative. So the next question is basically asking, if we add a catalyst, what would it do to the reaction? So if we add a catalyst, as we know, catalysts make reactions quicker. So it'll lower the activation energy. And because it's still exothermic, it might look something like this, because the activation energy is lowered, but it would still end up in around the same place. So that's number 3. Now number 4, basically we have this H2O2 that is dissolving into water and oxygen along with the catalyst. It's what we were doing above, basically, but with more data. So this question, number 4, is asking us what the number of moles of oxygen gas were produced in beaker 2. So looking at the data, we can compare the 43.09 and the 42.58 and find the difference of them. So we have this as part of our equation, and what I did was I put it over the atomic weight of oxygen, or O2 I mean, which will give us 0.019 moles basically, because it's asking us how many moles of oxygen were created, and as we know, oxygen's a gas and it'll just float right out of the container. So it would be easy to find if we just subtract the starting mass by the ending mass, find the molarity, and, well, we get this. So that's number 4. Number 5, we're supposed to calculate the mass of H2O2 that decomposed in beaker 2 during the 60-second period. So we have the H2O2 that's decomposing. As we know, H2O2, when it decomposes, it'll need 2 H2Os to get 2 H2O and O2, because we need to create water and oxygen as our product. So to balance that, we get 2 H2O2 and 2 H2O plus O2. So knowing this, we take the moles of oxygen that were created and we multiply it by 2, because remember, we need 2 H2O2s to make the oxygen. And then we multiply that by the molar mass, or atomic weight, of H2O2, which will give us 1.3 grams, because we're trying to find the mass, not the moles. So that's question 5. Question 6, you have the student continuing the experiment for an additional minute. So it's basically asking us, will the beaker above have more H2O consumed? Will it be greater, or will it be a lesser value that is consumed? And I notice on this graph that it looks like an exponential decay. So in the first minute, or first 10 seconds, I should say, we lose 0.13 mass, and then in the next 10 seconds we lose 0.12 12 mass, and then it just keeps going like that, slowly slowing down, and until we get to around 7 mass lost. So I said that the amount of H2O2 consumed will be slower because, remember, the exponential decay is right there on the graph. So that's number 6. Number 7, based on the data, the student claims that the catalyzed reaction has 0th order kinetics. Do you agree with the student's claim? I disagree. Because, remember, exponential decay, as I was saying in this one, it is not changing by a linear result. So it would not be 0th order. Because it's exponential. So, question 8 is asking that what would happen if we increased the amounts of H2O2, but then the student knocks over some of the beaker and a lot of the water is lost. I should say H2O2 is lost. So would this skew the results of finding how much oxygen was created? I said yes, because oxygen, as we did in one of the above problems, oxygen, remember, is created by looking at how much mass is gone from beaker 2, because it's a gas. And so if we remove some of this liquid right here, that would interfere with us calculating how much oxygen was created. So the answer would be very different, and it would be inaccurate. So that's question 8. Question 9, we have a balancing question, basically. So what we're trying to do is we're reacting this molecule with water, and the products we get are hydrogen peroxide and this molecule, ammonium bisulfate. So I first started by looking at how much of each element was in both. And I noticed that nitrogen and sulfur needed 2. So first thing I did was I doubled this to get me N2H12S2O10. And then after I got that, I noticed that I only needed 2 hydrogen and 2 oxygen. Or 1 oxygen. So I just added another water to this, and they balanced out. So the final equation was this. And that is FRQ number 25.